This video deals with the ideal gas law equation, PV equal nRT. You should recognize parts of it. You get the PV part from P1, V1 equal P2 equal constant, and P over T equal a different constant, D, and V over T equal another constant, F. It doesn't matter what these are, they're just constants. Well, if we combine these three, we end up with PV over T equals some constant C. And if we know the amount of gas, it turns out that the C is equal to N times R. And so that's where we get this equation, PV equal nRT, where P equal the pressure in atmospheres, volume is in liters, temperature is in degrees Kelvin, and N, a new term, is the moles of gas. You should all know what moles are, so we're just counting the number of gas molecules. In this case, R is a constant, and it's called the ideal gas constant, and it is 0.08206 liter atmospheres per mole degree Kelvin. There are other units for this. This is what we will use exclusively in our work, okay, on this. So all you're really going to have to be able to do is solve a problem using the ideal gas law. So I'll set one up. So here's our problem. How many moles of gas are contained in a 2-liter vessel at 3.75 atmospheres and 25 degrees Celsius? The secret to doing these is write out everything you know. So the pressure equal 3.75 atmospheres. The volume is equal to 2.00 liters. The temperature equal 25 degrees Celsius. And I got to convert it to Kelvin, so plus 273.15 is 298.15 Kelvin. That's about room temperature. And what else do I know? R equal 0.08206 liter atmospheres per mole Kelvin. And so I just set up my equation when I do these. PV equal nRT. I solve for n. Doing algebra, I divide both sides by RT. That cancels these, and I get n equal PV over RT. And now I just plug my values in, and I'll do them in a different color. 3.75 atmospheres. I put in all my units to make sure they work. 2.00 liters divided by 0.08206 liter atmospheres per mole degree Kelvin, and a temperature of 298.15 Kelvin. And when I do all this and stick it in my calculator, I end up with 0.3065 moles. I am not going to be concerned about sig figs in any of this, but you have to have enough. So I would always suggest using at least 4 sig figs in all numbers, and you'll not go wrong. That's it. So every problem is going to ask you to solve for a different variable on these. You'll have to be able to solve for any one of these variables, P, V, the temperature, and moles. Okay? Do the homework on these.